The James Webb Space Telescope has discovered something remarkable: beams of light that look like they come from a city shining from a far-off location. This discovery, made years ago, has rekindled interest in the possibility of life on other planets. The telescope concentrated its observations on Proxima Centauri b, the exoplanet closest to our solar system, and found it fascinating. Bright flashes could be warning signs of an alien civilization. Stay tuned for more. For many years, both scientists and the public have expressed excitement concerning the concept of life beyond Earth. Anything that points to the existence of life in space has been met with great enthusiasm. Then a breakthrough occurred. When the James Webb Space Telescope was built, it provided strong signs of life somewhere in space. While scanning the reaches of the cosmos, this powerful telescope discovered something extraordinary: lights that resembled those from cities located on a distant exoplanet. This raised the potential for extraterrestrial civilizations. This idea sparked a frenzy of anticipation and fascination among scientists, eager to investigate the ramifications of this finding. If confirmed, it could mark one of the most significant discoveries of our time. Hints that intelligent life may exist beyond our current understanding, organizing their cultures in ways we are just beginning to explore. Despite being light years away, these city-like lights astonished NASA engineers, who are curious about how long they could have been visible, waiting for human technology to advance enough to detect them. David Kipping, an astronomer from Columbia University, described the planet where these lights were observed as exceptionally complex. Unlike most rocky planets that absorb sunlight and release energy in the form of infrared radiation, this exoplanet behaves differently due to its unique relationship with its star, Proxima Centauri. The discovery made by the James Webb Space Telescope highlights the telescope's importance. Its ability to detect infrared wavelengths was critical in capturing Proxima b's unusual behavior, necessary for comprehending the planet's atmospheric conditions. Researchers plan to continue using this telescope to delve deeper into the planet's environment and even investigate its habitability. The James Webb Space Telescope is particularly sensitive to infrared light, allowing it to observe what happens on Proxima Centauri b during its night cycle. Detecting faint light in the vast darkness of space is challenging, but the Webb telescope can capture even the faintest glimmers, making it an ideal tool for confirming whether the so-called city lights on the dark side of Proxima b are real. The telescope can detect space-based artificial light if it falls within a narrow frequency range, much narrower than the light emitted by typical stars. Proxima Centauri b has a dynamic relationship with its star. One side faces the star, absorbing its powerful energy, while the other side shines as the planet orbits Proxima Centauri. This exoplanet experiences day and night cycles similar to Earth's, with extreme temperature variations. If Proxima b lacks an atmosphere, the temperature differences between day and night would be extreme. The day side would become scorching hot, while the night side would drop to below freezing temperatures. This dramatic thermal variation is a key area of interest for astronomers, offering clues about Proxima b's atmosphere. Thanks to the James Webb Space Telescope, which captures infrared imagery, scientists can effectively analyze the planet's thermal emissions and gain valuable insights into its atmospheric properties. Interestingly, the telescope's Earth orbit aligns with Proxima b's orbit, enabling scientists to make specific observations of the planet's day and night cycles every 11.2 Earth days. If the planet does have an atmosphere, the next step is to investigate its chemical composition to determine its potential for supporting life. The presence of molecules like oxygen, water vapor, and methane could suggest the possibility of life. This analysis involves studying the light passing through the planet's atmosphere, a complicated task, though the James Webb Space Telescope excels at analyzing planetary atmospheres. While the telescope cannot directly detect free oxygen, an important indicator of life, it can identify other crucial signs, such as ozone, which represents a healthy environment. As scientists examine the James Webb Telescope's data, the search for distant worlds continues, bringing us closer to answering the age-old question: are we alone in the universe? Nevertheless, it is important to remember that the James Webb Space Telescope can only observe a limited number of exoplanets for in-depth atmospheric studies. Astronomers will rely on ground-based observatories, such as the Extremely Large Telescope (ELT), set to begin operations in 2028, to provide a more comprehensive view of distant exoplanets and their atmospheres. Scientists are eagerly anticipating the launch of future space telescopes. In the meantime, the James Webb Space Telescope remains a critical tool for studying distant exoplanets. Despite its limitations, the Webb Telescope continues to provide valuable data that could radically reshape our understanding of the universe. Researchers now and in the future are planning next-generation telescopes capable of reducing the brightness of stars, allowing better observation of exoplanets orbiting them, similar to shielding your eyes from the sun to improve visibility. The next generation of telescopes will revolutionize our ability to study faint light reflected by exoplanets, bringing us closer to uncovering the truth about life beyond Earth. Exoplanets are more clearly assisting in analyzing their atmospheres and determining their potential to host life. However, this goal presents a significant challenge. One proposed solution is the use of coronagraphs, devices placed inside the telescope to block out the star's light while allowing the light from planets to pass through. By shaping the light waves precisely, coronagraphs can diminish the glare from the star, making the faint light from exoplanets more detectable. Another innovative technology is the starshade, a large, flower-shaped spacecraft that would fly in formation with a telescope, positioned tens of thousands of kilometers away. The starshade would block the starlight before it even reaches the telescope, allowing only the light from exoplanets to pass through. This method could be particularly effective for observing planets in the habitable zone of their stars, where liquid water and possibly life could exist. However, these technologies require extraordinary precision. For example, the alignment of a starshade must be perfect to within fractions of a millimeter across vast distances. Furthermore, these advancements must overcome the challenges posed by space missions, such as miniaturization, energy efficiency, and the ability to endure the harsh conditions of space. Despite these difficulties, the potential benefits are enormous. Successfully observing and analyzing the atmospheres of exoplanets could lead to the discovery of biosignatures, chemical indicators of life, such as oxygen, methane, or water vapor in specific ratios, which could suggest biological activity and point to the possibility of life beyond Earth. Researchers are also exploring ways to directly image distant exoplanets in greater detail. Future telescopes might be equipped with advanced adaptive optics that can compensate for distortion caused by Earth's atmosphere or the telescope's movements, producing clearer images. Combined with starlight blocking technologies, these improvements could allow scientists not only to detect exoplanets but also to map their surfaces and study their climates. The development of these next-generation space telescopes represents a significant leap forward in our quest to answer one of humanity's most profound questions. Are we alone in the universe? By enhancing our ability to observe distant worlds, we edge closer to finding out whether life exists beyond Earth, potentially revolutionizing our understanding of our place in the cosmos. As we move forward in the exploration of the universe, these advancements in telescope technology could fundamentally change how we look at distant exoplanets and the potential for life beyond our planet. The future of space exploration is brimming with exciting possibilities, with scientists hopeful that the combination of advanced tools like the James Webb Space Telescope and upcoming innovations will allow us to unlock the mysteries of the cosmos. With each new discovery, we are learning more about the vastness of space and the incredible diversity of planets that may exist, many of which could harbor conditions suitable for life. The idea that extraterrestrial civilizations might exist is no longer just a matter of speculation but is becoming an increasingly plausible scientific pursuit. The work of the James Webb Space Telescope, coupled with new technologies like coronagraphs and starshades, is bringing us closer to identifying exoplanets where life could thrive. As more data is collected from these advanced space telescopes, the search for habitable planets will continue to push the boundaries of what we know about the universe. The combination of infrared imaging, starlight blocking methods, and detailed atmosphere analysis is set to open up new frontiers in astrobiology, allowing scientists to search for signs of life in places that were once beyond our reach. The excitement surrounding these discoveries is palpable, as each new piece of information brings us closer to the groundbreaking possibility that we are not alone in the universe. The future of space exploration holds immense promise, with the potential to answer some of humanity's oldest questions about the existence of life elsewhere in the cosmos. In the coming decades, as technology evolves and new telescopes are launched, we may finally have the tools necessary to explore distant worlds in ways that were previously unimaginable. If we are successful in detecting biosignatures, or even confirming the existence of alien life, it would mark one of the most significant achievements in human history, transforming our understanding of life, the universe, and our place within it. As we continue our journey into the unknown, the role of telescopes like the James Webb Space Telescope will remain pivotal. They will allow us to peer deeper into space, search for the faintest traces of life, and expand our knowledge of the universe. With every discovery, we are one step closer to answering the most profound question of all. Does life exist beyond Earth? In doing so, we might just unlock the key to understanding the true nature of existence itself. So stay tuned, as humanity embarks on an incredible journey to explore the universe, with the potential to make discoveries that will shape our understanding of life in ways we have only begun to imagine. The search for life beyond Earth is just beginning, and it promises to be a thrilling ride that will captivate the imagination for generations to come. The journey into space is one of humanity's most ambitious and awe-inspiring endeavors, and with each new advancement in technology, we are getting closer to uncovering the universe's most profound secrets. The idea that we may one day confirm the existence of extraterrestrial civilizations is becoming more of a possibility than ever before. With tools like the James Webb Space Telescope and the development of groundbreaking technologies, we are poised to explore space in ways that were once thought impossible. The excitement surrounding the potential discovery of life elsewhere in the cosmos is palpable, and with each new revelation, our sense of wonder and curiosity about the universe continues to grow. Scientists and space enthusiasts alike are eagerly awaiting the results of the next generation of space telescopes, which will allow us to peer even deeper into the farthest reaches of space. The next phase in this incredible exploration involves harnessing new technologies to block out starlight, thereby enabling clearer observations of the faint light emitted by distant exoplanets. This technological leap is vital for studying the characteristics of these exoplanets and analyzing their potential to sustain life. The future of space exploration is not without its challenges. The methods and tools being developed to study exoplanets require unprecedented levels of precision and coordination. The use of coronagraphs to block out the star's light and focus on the light reflected by exoplanets is just one example of how scientists are overcoming these challenges. These devices must be finely tuned to ensure that the faint light from distant planets can be detected while eliminating the overwhelming brightness of their stars. In addition to coronagraphs, another exciting innovation on the horizon is starshade technology. This concept, a massive flower-shaped spacecraft, would operate in tandem with a telescope, blocking out the star's light before it even reaches the telescope's instruments. This method would be especially useful for studying planets located in the habitable zone of their stars, where conditions may be ideal for life to exist.